Welcome to Biology Made Easy. We are starting a series to discuss structural organization in animals. And in today's lesson, we are looking at embryonic tissues, and then we'll relate the embryonic tissues to permanent tissues. Welcome. So, what are animals? We have listed the animals here and their kingdom. We have animal coelenterates or cnidaria, kingdom coelenterata, and then we have flatworms, kingdom platyhelminths, roundworms, nematoda, segmented worms, annelida, echinoderms, echinodermata, mollusks, mollusca, arthropods, arthropoda, Chordates, Chordata. These are the animals. And we want to look at their structure in the embryo and how the tissues they have in the embryo turn them into permanent tissues to form specific animals. Well, in animals that have two layers of embryonic tissue, the two layers are known as ectoderm and endoderm. They have only two layers of these embryonic body tissues, ectoderm and endoderm. And these two layers of embryonic tissue finally become the whole organism, and so the organism is known as diploblastic, two layers in the germ or embryo, and those organisms are coelenterates. The two layers, ectoderm and endoderm, they are separated by jelly-like substance called mesoglia. So you have two layers of germ tissue, ectoderm, endoderm, separated by mesoglia and surrounding a gut. And these animals, diploblastic, they are coelenterates. Now, other animals have in the germ, in the embryo, three layers of body tissue, and they are triploblastic. They have three layers of embryonic tissue, and the three layers are ectoderm, mesoderm, endoderm, and these three layers encloses a gut, and they are known as triploblastic, three layers in the germ. And these triploblastic organisms, all the rest of animals are triploblastic. They are all triploblastic. But out of these triploblastic organisms, that's organisms where in the germ embryo, there are three distinct layers found: ectoderm, mesoderm, endoderm, surrounding a gut. There are some of the organisms that the three layers that surround a gut is solid, and they are known as acoelomate. Solid because there's no fluid-filled body cavity. So you have solid ectoderm, mesoderm, endoderm surrounding a gut, and they are known as acoelomates. So the triploblastic, we have acoelomates. And the acoelomates are flatworms. Then you have some triploblastic, that's the majority of triploblastic. They have a fluid-filled cavity that separates the mesoderm, the middle layer. So they are known as coelomates. So we have the coelomates here. They are also triploblastic. There's a fluid-filled cavity that is separating the mesoderm. This doesn't have any cavity in it. Acoelomate. This is coelomate. And the coelomates are the majority here. Nematodes, roundworms, segmented worms, echinoderms, mollusks, arthropods, chordates. They are coelomates. Now, we want to look at how the layers of embryonic tissue become structures in the organisms. And that we'll look briefly at the diploblastics, we'll look briefly at platyhelminths, and then we'll home in at chordates. So the diploplastics, the coelenterates, a typical example is hydra. So I quickly draw a hydra here. Briefly, the coelenterates, this is hydra. The whole organism, it has tentacles. The whole organism is soft because the whole organisms have mesoglia that makes it soft, that makes it flexible. So you can imagine that the ectoderm and the endoderm forms the tentacles, and the whole body with the gut opening as a mouth. That's coelenterates. Now we want to look at the acoelomates. That's the platyhelminths, flatworms. You have the ectoderm, mesoderm, endoderm, and the gut. No fluid-filled body cavity, solid mesoderm. So the gut opens out as a mouth here, and the rest of the organism is solid. Ectoderm, mesoderm will be part of forming the gut. This is the endoderm, and this is the gut. So the endoderm material will form the gut, and it opens as the mouth. So note the gut always opens as a mouth. This whole place here is solid mesoderm, no space. That is the flatworms. Now we are going to look at the coelomates, and we are looking at chordates, because in subsequent lessons we are going to look at the chordate, the toad, and the guinea pig or the rat, and do a dissection of it. Now, what animals form the chordates? We have cartilaginous fishes, that is chondrites. We have bony fishes, that's osteocytes. We have amphibia. We are going to look at the toad. We have reptilia, that's reptiles. You have aves, that's birds. You have mammals. And chordates, mammalia, will look at the human being. Now, this coelomate is this human being. This is how this human being was in the embryo. So the ectoderm, what does the ectoderm becomes in the human being or in the mammal? The ectoderm, you can imagine, becomes the skin, and it's the epidermis of the skin that forms nails, hair, etc. This ectoderm forms the brain and forms a number of nerves. It forms connective tissue of the head and face. And this ectoderm, it lines the surface of every structure that appears in the surface of the body. So you see, the gut will finally appear in the surface of the body as the mouth, and so the ectoderm lines the inside of the mouth. That's the ectoderm. The anus will finally appear at the surface of the body, and so the ectoderm lines all cavities that appear at the surface. And you see that the ectoderm has nerves and blood vessels, because the ectoderm should be able to sense what is happening in the environment and relay it into the inside. So the brain is ectoderm. The ectoderm has a lot of nerves, and so the body is sensitive to what is happening in the environment, because the outer part, ectoderm, forms even the brain and connective tissues that are sensitive to the outside. Very neat, isn't it? Now, after talking about the ectoderm, let's look at the endoderm, the internal layer. The endoderm lines the space, and so you see the endoderm forms the tissue that will end up becoming the digestive system, because here is the gut, and its material that forms it is the endoderm, and the gut will lead to the outside, the mouth and the anus. So the space or the area that is connected to the outside is the gut, and that's the digestive system. And you see the respiratory system too is connected to the outside, and so the endoderm also forms the respiratory system that takes part of the gut. The original gut in the embryo will form the respiratory system, because it will have to take air from the outside. This leaves outside, and the digestive system. That is the endoderm. And this is a whole coelom that has fluid, not fluid that fills it completely. And so the gut, look at the gut, the digestive system, and the respiratory system, and the systems, they are lying in this hole neatly. That is the coelom, the body cavity. Now, look at the mesoderm. Take mesoderm here, coelom, mesoderm. The mesoderm form the midline structures, the vertebra that holds mammal to support vertebrae, all other bones, muscles, smooth muscles, skeletal muscles. They are all formed by the mesoderm, reinforces the organism. You have urinary system, you have heart muscle, you have uterus, that is reproductive system. All those structures, they are formed, spinal cord, and the dermis of the skin is formed by mesoderm. So this organism in the embryo, the three basic layers of embryonic tissue, ectoderm, mesoderm, endoderm, with a coelom, that is the body cavity, will result in these. Meanwhile, some of the mesoderm form the dermis of the skin with all the blood vessels and the nerves. So, structural organization in animals, we've seen how embryonic body layers, three, end up forming the whole organism. So we'll meet in our next lesson. If the lesson has been useful, give us your likes and do subscribe if you haven't subscribed yet. Thank you very much. Let your comments flow. Goodbye.